Hello, today's objective is that you will represent verbally and graphically a transformed parent function. So that means that you are taking something that's written algebraically and then you either describe it or you graph it. This would be without a calculator. Obviously you can graph whatever if you have a calculator. For these examples, we're just going to be doing this verbally right now. So, first example, describe the transformation to the general function. You should have your graphic organizer in front of you when you do this. It'll say f of a x minus h plus k, and say what a and h and k do. So in this case, we have an a of negative 1/3. I'll write these down. And we have an h, and h in this case, it looks like 8, but that means we actually know it's negative 8, which means it's going to be moving to the left. And then we have a k of negative 1. So h is the weird one. You remember that from quadratics. It's the opposite of what it looks. And then a and k are whatever they are. So what this says is that our function has done several things. First of all, let's look at that h. Since h is negative 8, it looked like positive 8. That meant that this moved to the left. Normally positive would mean to the right in the x direction, but h is negative. So this function, whatever it is, because they didn't tell us, they just said f, has moved left 8. The k being negative 1, k makes it go up or down, and since it's negative, it's going down 1. And then a being negative 1/3 actually does two things for us. The negative tells us that it's reflected, and then the 1/3 tells us it's been compressed. So the negative means that this has been reflected over the x-axis. That's a vertical reflection. So that's all you have to write. And then the 1/3 means that it's either been stretched or compressed, and the dividing line is 1. If it's less than 1, which it is, then it's a compression. So this has been vertically compressed by a factor of 1/3, meaning it's like 1/3 as high as it would otherwise be. You notice we're just looking at the absolute value of a when we talk about stretch or compression, so just ignore the negative when you answer that part. So this is a vertical compression by a factor of 1/3. Sorry. Vertical compression by a factor of 1/3. You can write these four things in whichever order you want. It does not matter as long as you have all four. Next example. We have this time a specific parent function. You notice there's no f anymore, and it says describe the transformation in the context of the parent function. So let's just make sure that we all know what the parent function is. I'm going to write it over to the side. The parent function here would be x cubed, and you can see that little cube there. There's some other stuff going on, but that would be the basic parent function. So we know what a cubic function looks like. Kind of looks like an s, and then these things change that parent function. So again, just like last time, we have an a and an h and a k. Our a is 3. Our h is 0.5, positive because it's the opposite of what it looks like, and then our k is 9. Again, you can write up your description in whichever order you want, but we'll start this time by saying what type of parent function it is. So I'm going to say this is a cubic function, and that's our vocabulary that we learned in objective 3.3 about function families. So this is a cubic function, and then we'll say how it's been transformed. So I'm going to say that has been transformed I usually write h and k first, but it doesn't matter. So the h being 0.5 means that it's right 0.5. You can check your graphic organizer. So right 0.5. The k being positive 9 means that it's gone up 9. And then a being 3, well, positive 3 means that it hasn't been reflected, so we don't need to say anything about that. But a being 3, the absolute value being greater than 1, means that this is a vertical stretch. So I'm going to say finally that this has been vertically stretched by a factor of 3. I hope your handwriting is better than mine. So again, vertically stretched by a factor of 3 means that whatever this graph looked like, it's now been pulled taller and skinnier 3 times more than it otherwise would have been. So that is it for this objective. We have represented verbally, graphically you'll do in class, we've represented verbally a transformed parent function.